Hello and welcome to helpyourmath.com. In this video, we're going to look at writing equations of parallel lines when we're given a line that it's parallel to and 1 point on the line. In the first example, and this is the only time we're going to do this, we're going to look at both lines in the coordinate plane so we can kind of, verify visually that these lines do appear to be parallel. So what are we going to do? We're going to write the equation of the line in slope-intercept form that passes through -3, 2, and is parallel to the line 2x plus 3y is equal to 6. Then we're going to graph them both. Okay, so what do we need from this equation here? Well, we're going to graph it, so we'll need some information. But right now, what we really need is the slope, because parallel lines have the same slope. They have the same slope, and they have different y-intercepts. So we need to figure out the slope of this line, and then we know that our mystery line is going to have the same slope. We know a point that's on our mystery line, so we'll be able to figure out the line in slope-intercept form. Okay, how are we going to figure out the slope? If you want to, you can write this equation in slope-intercept form. So to do that, I want to get y by itself. So I will first subtract 2x from both sides. And that's going to give me 3y is equal to -2x plus 6. Now I'll divide everything by 3, all three terms by 3. And we end up with y equals -2/3 times x plus 6 divided by 3, which is 2. I need one thing and only one thing from this line, and that's the slope. The slope of this line is equal to -2/3. So that means that the slope of any line that's parallel to it, which I'm going to denote with the little parallel symbol, is also going to be -2/3. So now we know the slope of the mystery line is -2/3, and we know a point that goes through that line, -3, 2. What we can do is we can use point-slope form to get us one step closer to slope-intercept form. So point-slope form, that's y minus y sub 1 is equal to m times x minus x sub 1. And we plug in this -3 for x1 and 2 for y1 and then m for m. So this would give us y minus 2 is equal to -2/3 times x minus -3. All right, we want to clean up the right-hand side. First of all, this minus negative would become plus a positive. So then we would have y minus 2. Now I'm going to distribute the -2/3 is equal to -2/3 times x, and then -2/3 times 3. So I'm going to come over here, -2/3 times 3. I'm going to rewrite 3 as 3 over 1. And now I can simplify before I multiply because we have a common factor of 3 in the numerator and denominator. This gives me -2 over 1. Which is equal to -2. Hey, the fraction canceled. That's nice. Last step to get this in slope-intercept form, I'm going to add 2 to both sides. And we end up with y equals -2/3 x, and then -2 plus 2 is 0. So we would just write y equals -2/3 x. So that is the equation of the line that is parallel to the given line. Now it's asking us to graph both in the same coordinate plane. So the given line, which was this 2x plus 3y equals 6. Remember, we rewrote it right here in slope-intercept form, so you can use either form to graph this line. I always like slope-intercept form. We can start at the y-intercept, which is 2, so that's up 2 from the origin, and then use the slope to graph another point. So it's telling me go down 2 into the right 3, down 2 into the right 3, or what I can do is I can go up 2 into the left 3. Up 2 into the left 3. Oops, I lost track there. 1, 2, 3. And we want to use a nice straight edge, which I don't have the luxury of having. And we're going to graph it as best we can. So this was the given line. So I'm going to say that this was given. So the line that we wrote the equation for, which I previously called the mystery line, I don't see a y-intercept, so it's 0, right? Remember, it was right here. -2 and plus 2 made 0. So we would start at the origin. That would be the y-intercept, 0, 0. The slope tells me go down 2 to the right 3. Go down 2 to the right 3. Or I can go up 2 into the left 3, up 2 into the left 3, using a straight edge, or in my case, I'm going to try to freehand it and probably totally botch it. That wasn't so bad. And you can see if you used a straight edge, mine do look like they're going to meet because I can't draw sideways on a screen. But if you were to draw these, they would look very parallel. They would look like they would never meet ever. And that's the idea of parallel lines. Let's look at a few more examples. Okay, so we're going to do the same thing here, except we're not going to graph. We're going to write the equation in slope-intercept form of the line that's parallel to the given line through the given point. So we have this line here. What's the one thing that we need from the given line? I didn't hear you say it again. We need the slope. So I'm going to write this in slope-intercept form by subtracting 2x from both sides. That gives me y equals negative 2x plus 6. All right, so I know that the slope of the given line is negative 2, and the slope of any line parallel to it will be negative 2 because they would have the same slope. So we're going to take the slope of the mystery line, and we're going to take the point that's on the line, 2, 5, and we're going to figure out what the equation of this line is in slope-intercept form. Notice that from the given line, I didn't do anything with the y-intercept with that 6. I don't do anything with it. We're not going to graph it. We don't care what it is. Sorry, no offense, 6. But we don't care. Really important that the only thing we take from that line is the slope itself. I'm going to plug into point slope form, and remember that's y minus y sub 1 is equal to m times x minus x sub 1 to help me get this equation in slope-intercept form. So this is x1 and this is y1. This will give me y minus 5 is equal to negative 2 times x minus 2. Distribute the negative 2 and I can add 5 at the same time if I want. And we get y equals negative 2x. Negative 2 times negative 2 is positive 4 plus 5 because I added 5 to both sides. And so the equation of the line that's parallel to that given line is going to be negative 2x plus 9. And there we have it. All right. Always, I encourage you, pause the video, try this one on your own. In this case, we have a little bit of work to get to determine the slope. So first thing, I'm going to subtract 2x from both sides. That's going to give me 3y is equal to negative 2x minus 12. Divide every term by 3, and we end up with y equals negative 2/3 x minus 12/3, or 4. What's the one thing I need from this? The slope. The slope of this line is negative 2/3. The slope of any line parallel to this line will be negative 2/3. I'm going to take the slope of our mystery line, negative 2/3, and we know one point on the line is negative 6, negative 1. And I'm going to plug these in. I'm going to use point slope form again because I like point slope form. We have y minus y sub 1 is equal to m times x minus x sub 1. And let's plug in. We have y minus negative 1. Be super, super careful with that. It's already a minus from the formula, and then y sub 1 happens to be negative 1, so it's y minus negative 1 equals negative 2/3 times x minus x sub 1, which is negative 6. In both cases, I can rewrite those as positives. Y plus 1 is equal to negative 2/3 times x plus 6. I want to distribute the negative 2/3, and I want to subtract 1 from both sides to get y by itself. This would give me y equals negative 2/3 x, and then over here we have negative 2/3 times 6, which we're going to write as 6/1. Negative times positive is negative, and I can simplify before I multiply, so I want to do that. Negative 2 times 2 is negative 4/1, which would be negative 4. So now I have minus 4 minus 1 because I subtracted 1 from both sides. Final step, y equals negative 2/3 x minus 4 minus 1 minus 5. So this is the line. Should have the same slope as our given line, which it does. Different y-intercept, which it barely does. Whoa, it was so close. Y equals negative 2/3 x minus 5. In our last example, we have x minus 3 equals, wait a minute. Wait, we're missing a y here. So this is a special type of line. This is a vertical line, and it might help if we just rewrite it as x equals 3 if I added 3 to both sides. Well, here's the deal. So we're looking for a line that has the same slope as the given line. But x equals 3, what's the slope of that? The slope is undefined. So what do? Well, that means that any line parallel to this vertical line will also have a slope that's undefined. So any line that's parallel to a line that says x equals something will also be x equals something. How do we decide which x we use? How do I know what it is? How do I know if it's 4 or 12, negative 6, pi? Well, look at the given point. The given point has an x value of 2 and a y value of 3. This is what we want to use. We want the x value. So what vertical line passes through the point 2, 3? That would be the vertical line x equals 2. So that would be parallel, x equals 2 would be parallel to x equals 3. They both have slopes that are undefined. These have been examples of finding lines that are parallel to given lines, given a point on those lines. Thank you for stopping by.